My name is Nur Natasha Amira binti Manasir and my metric number is AE 200041. And now I will explain for the activity 1, number 1. For this activity, all the parameters of Wheatstone bridge has been given and we need to copy it back to get the ammeter reading. The value of R1 is 10 kilo ohm, value of R2 is 2.2 kilo ohm, value of R3 is 30 kilo ohm, the value for battery is 10 volt, and the value of Rx is 5.6k. And this is the ammeter. And then we run the simulation. After we run the simulation, the ammeter value shows so far from 0. And then the value of R3 was adjusted to get ammeter reading that has the nearest to 0 and positive 0.41 microampere. After that, for the value of unknown resistant Rx was verified by using equation 5.3 and the value got is 6.6 kilo ohm.
Hai, nama saya Pravindas Anagi Kandan. So saya ni hari ni nak buat Wheatstone bridge saya. So kalau ikut lab ni 10k, ni 10k resistor. Lepas tu Rx ikut nombor metrik saya 202 kilo ohm. Lepas tu R3 saya yang maksimum adalah 220 kilo ohm. Lepas tu bateri 1 watt, 1 volt. DC ammeter, micro ammeter. Lepas tu saya nak run. So sekarang ammeter saya negatif 100. So saya nak adjust sampai datang kosong. So sekarang meter saya adalah galvanometer saya dah kosong.
Greetings to Dr. Cairo Anwar. My name is Ishwaran Murugan. My matrix card number is AE190089. Today I'm going to explain you all about the activity 2 for lab 5 and lab part 1. For the first step, we are going to set the voltage to 12 volt and switch on the board. The switch on button is here, so we press it in switch on. So make sure the switch is in short mode. Now we are gonna, for our case, we need a 2 ampere. So we are gonna adjust the RS until we get a value of 2 ampere. Thus, once we adjust it, when the is 6, RS is 6, we'll get the value of 2 ampere. The next step, we make sure that all the resistance was set to 1000 because the given value initially for us was 1000 ohm. We set everything 1000. Once we set the 1000, now we can go to the next step. So for the next step, the switch S was put in a open mode and the resistance S, which is the RS, was set to 0.01 ohm. 0.01 ohm. Now once the value is set, now we can set the switch S to bridge mode and the switch K to open. As we see, we will get a value of 0.00000 millivolt. So now we can close the switch. When the switch K is closed, we will get a value of which is somewhere around negative 0.009 millivolt. In order for us to get a null is achieved, which is the value of millivolt must be closest to 0. Thus, we need to adjust the value of RB. So for our case, the value was adjusted until we will get a positive value or closest to 0. The value was keep on adjusted. Okay. So this was the closest value to 0, which is when the resistance RB was 1018.20 ohm. So now, since we will get the closest value, which is 0.001, we can calculate the unknown resistance value, which is the Rx. So once we press the Rx, we will get a value of 0.000982. In order to prove this step, we have done the manual calculation. The manual calculation using the formula Rx equals Rb times S over Ra. So we will get the value somewhere around 0.001, which is similar to 0.00982. When we round off, we'll get somewhere like 0.001. That's all from my part. Thank you.
Greetings to Dr. Khairul. My name is Shankar Nalaki Subramanian, matrix ID AE190090. So I'll be presenting about the next part where we will change the S resistor. So we start over again. The voltage source has been set to 12 volt and it's connected in short. The switch S is connected to short. Adjust the rheostat and maintain the ammeter to 2 ampere. So if you were to adjust this, it will give exactly 6 ampere. Let's run this. Sorry, 6 ohms on the rheostat will give us 2 ampere of current flow. And then switch S is set to open mode, and resistance, low resistance value is set to 0.005. So it's currently 0.005. We just leave it at that. And then switch S to bridge mode and switch K to open mode. Now we should set the values once again. So each of it will be 1000. Each of the resistor is 1000. After inserting the values of each resistor as given, each of it is 1000, and this should be it open. So we from here we are able to observe the galvanos, the millivolt meter. And now when we set this to close, the reading alters a bit. So now we need to vary the resistor RB and RB here. So this has already been simulated, and the value that give us close to 0.00 is 1008.1 ohm resistor. So as you can see, when I increase or decrease it, there's a negative here. It's still it doesn't give us a perfect 0 in the millivolt meter. So this is as close as we can get to it. And when the deflection is 0, we are able to calculate the unknown resistor. So the unknown resistor is about 0.00495. This value has been further proved and recalculated over here. So this is the calculation where Rx equals to Rb dot S is the unknown resistor, over Ra. So just now we set it to 0.005 ohms, and the previous activity we set it to 0.01 ohm. So from this calculation, we are able to find the unknown resistance X is 0.005 ohm, which is similar to the calculated way if we round this off, which is approximately 0.00495 ohm. So that's all for activity 2, part 2. Thank you.